Good morning, everybody. Welcome to Credo's webinar on how to generate money from machine learning. Today's webinar will talk about MLOps. It's the machine learning equivalent of DevOps. We'll talk about the challenges and some of the pitfalls when setting up machine learning products and data products in an MLOps fashion. Most of you don't know me. My name is David van den Abela. I'm originally a physicist turned number cruncher. I've been number crunching for 3 decades in engineering, in finance, and also in data science. Before we hop into the presentation, maybe a few housekeeping rules. First of all participant audio is muted from the beginning till the end of the webinar. That's pretty lonely for us sitting here in lockdown, of course. So please feel free to ask questions via the live chat, and you've already discovered it. It's in the chat bar on the right of your window. Another way we'll engage with you is through a poll somewhere in the beginning of the webinar. I'm not giving the talk alone. Next to me is sitting my colleague Radovan Parak. He's originally a financial economist, and he's spent more than 10 years now guiding big financial institutions in their data-driven journey. Rado, I give you the word, and I congratulate you with your new haircut today. We're not used to that. So
Thanks,
can you...
David. Thanks for
Yeah,
the
okay.
warm welcome. Guys, good morning. So yeah, today I would like to propose with this webinar actually solution to two problems that I typically encounter at our clients. The first problem is that not many are aware that data science is a game of increments. So it's not enough to have one almighty model. You need to have tens of them or hundreds of them. And the second problem is a consecutive from the first one. In order to have or keep tens or hundreds of models in the air, some teams at our clients, they have already uh, realized that they need to do so, but they start to build their setups organically, and in no time they end up in technical debt, in bottlenecks and operational errors. So what I would like to show you today is how to build machine learning products in a sustainable way. That's what I do. That's what I do at Credo as well. Uh, Thanks, David.
Okay, after this dire warning of Radovan, let's look at what's on the menu for today. So we've introduced ourselves. You cannot introduce yourselves, but we'll have a little poll for that. I'll quickly talk about Credo, then the problems and solutions we see in becoming data-driven from the machine learning point of view, at least. We'll illustrate new technology and MLOps techniques on data science and pure MLOps in a real hands-on use case. The Q&A as said during the webinar, I hope to have some questions. There may be too many questions. In that case, I will filter, but that would be a luxury problem. So I look forward to hearing from you. Very briefly, Credo. So we've been around since 2001 in the Benelux and the Czech Republic. We make heavy number crunching software for banks and insurers. And when we do data science, we can go actually broader. We're very niche end-to-end. And we offer our own software and the consultancy that comes with it. We have a number of products. So we do data modeling for financial institutions to structure the data warehouses and big projects. We have a risk and finance platform. We won't talk about that today. So the focus is really YQ. It's our cloud-based MLOps platform. So we'll show how you do MLOps with it. And there's another small component that's definitely relevant for today, but we don't have time to talk about it. That's our data masking tool to make our clients GDPR compliant. You cannot just put all your client data in the cloud without precaution. Okay. Before we get started, I would need to know what the audience is like. Are you very advanced in MLOps or not? So there's a little poll and it goes like this. So A, I don't really know what MLOps is. B, I have a basic understanding. C, you have that basic understanding and you're actively considering adopting it in your team or company. And D, you are already actively applying MLOps. And now I'm going to start a poll. And you should see these questions. If not, let me know via the chat window.
Oh yeah. Yeah, I can see that the replies are coming back.
Okay.
Or at least I hope that's what's happening with
Yeah,
my
I
limited
see
knowledge of.
the first answers, but I don't see the final answers here. So let's go back to the polls, look at the results. Yeah. Okay, and now I'm going to share the results with you. You should be able to see them now. So the vast majority has a basic understanding of MLOps, but there's also 30% not knowing what MLOps is, and then yeah, a majority that is considering adopting it or already using it. So we'll not go into too much technical detail in this webinar, but for the more technical guys, please bear with us, because at the end it will definitely get up to the level that you expect. Okay. So I continue with the slides now. Right. So what is the main problem we see with our clients? Well, the greenfield clients, definitely they start by hiring data scientists and making some machine learning scripts. The fancier, the better, preferably AI. But that's really not the challenge, the real challenge for our customers. The real challenge is creating, running, and keeping track of lots of ML scripts in batch and real time. And I'll show you on the next slide what that actually looks like in a bank or an insurance company. So you would have scripts that tell you that a client's credit card is blocked. You don't want to contact that client to sell anything because the client is upset. You have simple scripts that record that the client has its 18th birthday, a baby was born, you just got married, and the director of your branch agency may want to call you and congratulate you. Then you have real predictive models or prescriptive models for upsell or cross-sell of products of the company. You have churn modeling to predict which clients are likely to leave the company and go to a competitor. Models that say which companies are unlikely to pay their insurance fees, and models that say which clients are likely to default, and so on. So that's the challenge. It's a lot of models, and you have to play on them simultaneously to generate added value. Radovan asked, please don't show the next slide, because this will be the only image that will stay in the head of the audience. So I'm definitely doing this. So here you see the cat in the hat. That's a figure in a book I'm reading for my 4-year-old son now. The cat in the hat likes to keep lots of things in the air, and he's quite good at it, but he's not organized in an MLOps way, and he doesn't have the necessary tooling, and so it actually doesn't end well. You need to have organization and tooling to keep tens or hundreds of scripts in the air and maintain them. Right. Now, let's have a quick look at the technology that has made MLOps available. So MLOps makes a lot of sense, and it should have existed a long time ago, but the underlying technology simply wasn't there. One thing which most of you have probably heard about are containers. So containers basically encapsulate a full runtime environment with all the supporting libraries, all the configurations to make an application or a script run. So you could have an old Python 2.7 script. It will be in its own container with the necessary Python 2.7 libraries and packages. And it will keep on running even when the whole company upgrades to Python 3.6, or you change from Google Cloud to AWS or whatever, or you go back on premises. This is just completely future-proof and very, very robust. It's not as simple as that. You need to run containers somewhere, and the most popular platform, I think, to run containers is called Kubernetes. This is a Google open source solution to run containers, not on a single machine, but actually on a cluster of machines. And Kubernetes will just put the container wherever there is space and manages the available capacity in a very efficient way, much more efficient than you see in many existing machine learning suites of the big cloud vendors themselves today. You can really think of it as an operating system, so for a group of machines in the cloud or on premises, wherever. Then if you run Kubernetes clusters in the cloud, the nice thing is on the bigger vendors, at least, these are scalable. So if you don't have enough capacity, you need to run this big Spark job once a month. We will fire up 100 machines for an hour, the Spark job runs, the machines go down, and you continue. So that's very cost effective and a lot more ecological than having 100 node Spark cluster running 24/7, which is the reality at many of big banks and insurance companies today, actually. And if you have all these things, well, you have containers containing machine learning scripts. You have to be able to glue them together and make them work in a reliable machine learning fashion. There's a lot of open source software. I don't know if you have followed the webinar of Go Data Driven at the beginning of the week, but they had an impressive slide with like hundreds of tools. So you have to be careful which one you select because they come and go. We've looked at it very carefully and we joined the Kubeflow community. That's like next generation MLOps platform being developed by Google, Dell, IBM, Cisco, Microsoft, Intel, about 30 contributors, amongst which an interesting Belgian Czech company called Credo. So that's really what makes it MLOps. So our own platform is mainly powered by Kubeflow and by a number of other open source components. And there is, of course, our own glue that holds it all together. And the things we add is stability and continuity. Kubeflow changes all the time. All these components change all the time. They need to talk to each other in a secure way. So we provide SLAs, stability and continuity. It's easy to put lots of open source components up in the cloud. It's a lot of fun, but then they have to talk to each other and transfer identities and so on. And then that's where the fun stops and it becomes hard work. So that's one of the things we do. Auditability, making sure that you can redo trainings and you find the same results. Ease of integration, and then really MLOps. And you may wonder why not simply use one of the easily available solutions of the big cloud vendors. A number of reasons. First, total cost of ownership. The second one, this is really an MLOps platform. It enforces MLOps working, whereas the other platforms are more generic and you will have to improvise a bit. And I don't see that changing because the client base is too broad. And a third one is portability. So you can migrate from one cloud vendor to another to on-premises anywhere you want. And these migrations happen. We're doing one for a bank now from one platform to another platform in the cloud. Right. Is what I am telling understandable to you guys, or am I talking Chinese? Because I don't see any questions in the live chat. This is not very reassuring. So Rado, please take it slow.
Yeah, there is someone responding that indeed they are currently experimenting with Kubeflow.
Okay, very well. Good to hear this.
Okay, okay. So people are there; they are not sleeping.
Okay, and experimenting with Kubeflow. Perfect. Okay, let's now have a look at conventional data science. So this is not yet MLOps, but doing it with this new tooling that I just presented. And Rado will give a short demo on both the technology and the functional aspects. The technology contains the idea of a scalable notebook server that will look on the Kubernetes cluster, what is available. Modeling notebooks, most of you know this, but there are always like 25% in the audience that have never seen this. So we'll quickly go over it. The concept of workspaces to organize your collaborations and set up security. Kubeflow pipelines, versioning, and then we'll deploy a real-time app from a notebook and we'll show how it can be monitored live with dashboarding tools. Rado, I'll now give the screen to you and you can give that first demo.
Okay, thank you. You need to stop sharing.
Yeah.
All right, perfect. And now I start to share. David, please confirm when you see my screen.
I see your screen.
Okay, perfect. All right, guys. So what I'm going to do is I'm going to show you the tool, and I'm going to show it in two modes. In the first mode, in the first part, I'm going to touch upon some concepts that might seem a bit unrelated at first, and in the second part, we actually show a narrative, a story that will connect all these concepts and show you the MLOps way of working. So the first part is a bit more introductory. The second one is a bit more advanced. So we start with the notebooks, as David mentioned, or actually with the notebook servers. And this is actually a notebook server pane in Kubeflow where you can create your own notebook servers. Now, a notebook server is, you can imagine it, for those who don't know, it's like a laptop in a physical world, equipped with all the tooling you need to do the data science. And as you can see, you can create different notebook servers in your workspace. I'll talk about workspace later. If you would like to create uh, a new notebook server, you just have a wizard. You can give it some kind of a name. You can select from predefined Docker containers, and it's Credo who is defining and maintaining these containers. So you have different containers for different use cases prepared with certain set of libraries, etc. So for
Spark,
instance,
R, Python, and so on. Yeah.
exactly. And you can also define resources. So for smaller jobs, you can go with smaller notebooks. For larger one, you can go with very large notebooks, for instance, with the 64 gigs of memory. And you just basically, a lot of things are pre-filled, and you go to the end and you hit the launch button. And in few seconds, you would have your notebook up and running. I'm not going to do it because, as you can see, I already have one notebook prepared here. But before diving into the notebook, I also want to touch upon the concept of the workspace that David mentioned. So workspaces are basically a organizational unit in Kubeflow. You can see that here I am part of 4 workspaces. I'm owner of 3 of them and contributor to 1 of them. And basically each notebook is living in a workspace. So it's a way how you can shield resources, computational resources from one another. And if I change my workspace, you can see that here I have another notebook, and it's built in. It's using a different image. So this is basically as if you would have several laptops with different installations. You can have different operating system, different toolings, etc. But it's all virtual. It's all on the cloud. So that's pretty cool. I'm going to go back, and now I can connect to my notebook. So when I connect to it, you will be redirected to the landing page of a notebook server, which is a Jupyter Lab. Let me close this one because I have one open here. So this is the landing page of the Jupyter Lab. For many of you, this is the bread and butter, so you know this. But for those who don't, this is a Jupyter Lab technology. It's an open source for creating notebooks. A notebook is basically one of the development environment for data scientists. And the nice thing, let me just run the whole notebook for you here. This is, by the way, a notebook about credit risk modeling. The nice thing about notebooks is that you can combine the narrative, so the story, your documentation, with the code and with some visualizations. So you can see the notebook is composed from the cells, and each cell is containing either a documentation or a code or some kind of visualization. So in the end of the day, you can compile nice reports that you can share with your colleagues, or you can use them for presentation towards the rest of the organization. And another good thing about the notebook server is that we hooked up a Git extension to them. So you can see here, my apologies, you can see here a Git. Normally you see it here. Yeah, so you can see there is a Git pane, and you can see all your changes, and you can do your typical Git work. You can track it and trace it. So these are the basics about the notebooks. I believe I explained everything what I wanted. The next thing that I would like to show you, it's a different concept. It's a concept of a pipeline. Now for that I changed to another window, and basically when you have your code ready, you typically want to run it, and you want to run it repeatedly, and you might want to change something, and you want to glue it together with some other part of a coding. You basically want to create a workflow, and that's what pipelines are very good for. So I'm running now one pipeline for you, and as it will run and unfold, I will explain what it is. So this is running now live. This is a pipeline that I prepared. This particular example is a pipeline about training and prediction from a trained model. So it's quite a complex one. And the pipeline, as you can see, it's basically an implementation of a workflow. And it's an ordered set of certain steps, and each step is basically represented by a Docker container. So that's the containerization that David was mentioning. So each step contains its own runtime, and there is some code running inside of that runtime. And the nice thing about this is that because it contains its own runtime, you can combine different runtimes. For instance, in this particular pipeline, I'm running a data preparation step, which is actually a SQL step. So I'm executing a SQL code in a remote database. And the rest of the steps are pure Python are pure Python steps for feature generation, and then for model fitting, and then I'm using the fitted model to do some predictions. And you can then send the results. Here I just plot them. Here I just print the results to the console just for the sake of illustration. So these are pipelines. We will get to how you can use them and utilize them effectively in the second part of the demo, but just here to give you a glimpse. What is the next thing that I wanted to show? Yeah, okay. So this would be one way of creating the workflows by chaining your scripts. But sometimes you also want to deploy a model, like a real-time model, turn a model into machine learning product, into real-time app. And there is also a way to do this with the Kubeflow technology. There is a functionality called fairing, which is one way of deploying real-time models. And basically, it boils down to wrapping your code in in some kind of Python class. I'm not going to go into the details. I'll just execute a few lines of a code. Then you set up the deployment backend. So you basically say where you want to deploy your model. I'm going to deploy it in the Azure Kubernetes cluster. And then with these 4 lines of a code, you can create a prediction endpoint. And now a lot of heavy lifting is done by Kubeflow itself. So I executed this line of a code, and what is happening in the background is actually that your model file, so something that you've developed in your modeling notebook, is being injected into a Docker file, in the Docker container. A new Docker container is created that contains your notebook, your model, and the new notebook, and the new Docker container is deployed to Kubernetes, and there is an API built around this, and the API is basically an interface. That's the way how you can communicate then with your real-time model. And there is a prediction. Well, there is kind of an endpoint deployed, and that's basically a URL which you use to communicate with the model, and that is presented here directly in the notebook. So you can now take this URL. This is really now a living web application, and you can take this URL and you can communicate with your model that you deployed. And the final piece of technology I want to show you is dashboarding. And why? Because when you have a model like this deployed, you can start working with it. You can start targeting the model. And when you start target the model, you want to be able to monitor it, and you want to be able to create some kind of dashboards to see how it performs. In order to demonstrate that, I prepared a kind of a simulation study where the model I just deployed, I'm going to target it with some requests. So in this case, I deployed a credit scoring model. That's a really typical use case in banks. And I created a small simulator that is going to simulate like 500 credit applications every 10 seconds. And it's going to target the model with them. Let me just execute the simulator. And the model that I just deployed is going to reply with some scoring results. So basically, whether a given client should get mortgage, yes or no, and then we are going to present this in a small, simple dashboard. So this would be the dashboard. What I want to mention is that the dashboard itself is not part of a Kubeflow. It's a different technology called Kibana. Kibana is part of the Elastic Stack. We are using different type of dashboards in our YQ solution. This one is for functional monitoring. So what you see in front of you is very simple dashboard. I'm only measuring one metric. And also if there is a credit risk modeler in the audience, he will be familiar with it. The metric is called PSI. PSI stands for Population Stability Index. And simply put, it's basically measures what is the difference between the distribution of the scores coming from your training set compared to the scores that are coming from your live model, so that you can see on this plot. So if these two plots, the blue one and the violet one, are close to each other, if the distribution is close to each other, then the PSI is low, and that's fine. That's what we want to see. That means that the model is working okay. And if we would see that the PSI increases, then that would signal that there is something going on with the model, and we should probably retrain. And this is the thing I would like you to remember for now, because we are going to come back to this live demo, and I will show you some things on it in the second part. But for the time being, let me just pause the demo here, and I will give floor back to David to give you some introduction, and I will jump back. David?
Thanks a lot, Rado.
I will stop sharing my screen, and the floor is yours.
Right, so I go back to where I left. Before we go to MLOps, data science on steroids, are there any questions about the presentation until now? No questions, so then I dive into MLOps. There's an interesting article by Seto, Weider, and Windhauser on the web. You can see the link on the top of this slide. It shows the full life cycle of a machine learning product. I'm not gonna dive into the details, but rather look on three big blocks that you can see in there, three big silos. The first one is the silo in which scripts are developed by data scientists or data engineers. Usually they do a couple of experiments and then they select a final script. If you go to one of the early adopters in the banking or finance world, you see that that's really a silo. That's the data science team. And when they are ready, they deliver their scripts to the application builders. So these are the ones that go into create the actual pipelines or web apps. And that's another team, more IT oriented. And they take the scripts of the data scientists. They don't like the scripts. They rewrite them completely, maybe even in another language. 3 months later, they come back. The data scientist is not happy because he didn't hear anything. And the application is not what he or she had in mind. And there you go again. And then when these two silos agree, then you have to go to the third silo, and that's the silo that actually operates the models, puts them live and operates them. And then you can also have nasty surprises because it's probably another environment than the ones used by the data scientists and the development people, and there can be, again, problems. So that's highly inefficient, and you find the same in deployment of classical IT products, for instance, websites that have to be updated all the time. If you work in this way, it's very inefficient. The efficient way in IT is called DevOps. You basically integrate these three teams, you put them closer together, maybe in one team or with close links and a single set of KPIs. And you also give them a unique technology that is shared by all of them. So if you do that, then what you typically see in IT, but also in quite different context of data science. Well, so you have the technical enablers. Huh? So the first thing when you put the teams together is that they make sure that the operational environment is identical to the development environment and the test environment. And with YQ and Kubeflow, that's the case. The environment is called Kubernetes, so you don't have that problem. Then everything is written as code, even the pipelines and the real-time apps. You have many data science applications where you can just drag around blocks and put lines between them. That's very nice, but under the hood, you still have code, so it's no different. And the nice thing about code is, of course, that you can version it in one repository that everybody uses coherently. And when you've reached this step, then everything starts getting automated. You automate the building of new apps. You automate the testing of these apps. you automate the deployment, and you automate the operation and monitoring of data and machine learning products. So that's really the efficiency boost that's released when you join the teams and you provide the right kind of technology. Okay, so Rado will give a demo of this and how you can actually monitor, retrain, redeploy a model on the fly with not a huge team, but a very small team. And in this case, an extremely small team, a one-man band called Radovan. And the demonstration will talk about pipelines as code, about artifacts. Artifacts are, for instance, the binary object that represents a trained model. If you use neural nets, it can take many hours to train a model, so you don't want to retrain, you want to version that artifact. That's a difference with classical DevOps, by the way. You also have to version some binary objects and some data, not just code. Then how to experiment efficiently, how to deal with metadata, and how to set up a continuous integration and continuous deployment pipeline. In this case, so the rapid model retraining and deployment I talked about. So Rado, I give the floor again to you for the second demo.
Yeah, thank you, David. But we got one question from Gerben asking, how do Kubeflow pipelines integrate with CI/CD principles? One pipeline per environment or some meta approach? That's a nice question. So the way how we go about it with YQ is that we actually have two Kubeflow clusters. One is what we call a lab or experiment cluster, where data scientists are living and they are creating their Kubeflow pipelines or their web apps. And then next to it we have another cluster called deploy or deploy and operate, and that's more automated cluster. And in between the two clusters, we have repositories. We have a code repository, but we have also artifact repositories, etc. And basically the CI/CD pipelines, they live on the top of this system in between the two clusters. So and these CI/CD pipelines are implemented by YQ. And basically, it's a way how you transfer your Kubeflow pipelines and web apps from the lab side to the production side.
There's also
So
training, of course. So
but of course,
yeah. The training pipelines are another example. These would be on the lab cluster. The test pipelines would be on the lab cluster.
Yeah. David, if I may ask you to stop presenting such that I can take over.
Yeah. There you go.
All right, perfect. Do you see my screen now?
Yep.
Or we have the bug?
No, no.
No?
No.
So you see my screen?
I see you. I see your screen.
Okay, good. That's all right. We were expecting a bug. It normally happened when we were preparing. Okay, so can you still see my screen?
Yep.
Okay, perfect. So in the previous part of the demo, I gave you a bit of a walk around different concepts, and now I'm going to try to tie them together. I will start from a point where I have created my pipeline, a simpler one. So I'm not going to use the gigantic one from a previous step, but this is very simple pipeline for training machine learning model, in this case, a credit scoring model. And the first thing what I want to show you is, and David already touched upon this one, is that this is a graphical representation, but in fact underneath there is a code, and the code looks something like this. So the code is basically composed from steps. So you have for each step you have a piece of a code. For instance, this is a step 1, which is corresponds to this this step here. And the step and the code is basically describing two things, or you need to define two things. First is the business logic. So that's basically what you are actually doing with your pipeline. So this is something that data scientists normally define in their modeling notebooks. So this is a copy paste from the modeling notebook I've been showing you. And then there is a second part to it. And the second part is basically where you define the infrastructure. So where you define the place or the infrastructure on which the code that you define here above will run. And you can see
Rado,
that's
sorry to interrupt, but I'm no longer seeing you speak, and I'm no longer seeing the screen move. Are the participants still seeing Rado talk and see the screen move or not? Please let us know. Frozen.
okay.
So
That's
uh,
uh, that's the
yes,
bug I was afraid of.
okay. So
I do.
apologies, but
Well, Jonathan said I do. I still see Rado.
yeah, I see you, but I
No,
don't see you
frozen for
talking.
me too. Okay, guys, so I'm trying to, yeah, frozen as well. All right. Our apologies. I'll try to restart and come back to you in a sec.
Okay, so yeah, Radovan will re-log in. It's the small bug in the webinar software. Yeah. It
Okay,
would be, yeah, okay, there
I'm
you go.
back.
Share again.
I will share again. All right. And here is my code. Okay.
Yeah,
Can you see now what I'm
yeah,
showing?
yeah.
Okay, so I'll take it from the start very quickly. So as I mentioned, each step of a pipeline is represented by a piece of code. So you can see the step one here is represented by this code, and in the pipeline it would appear like this. And in order to do this block, you need to have two pieces of code. One which is the business logic. So that's this what you can see here, and that's basically the copy paste from your modeling notebook. And then you also need, with this kind of one-liner, you need to define where your code is going to run. So you need to select a Docker image that you want to run it in. And if you combine these two things, so the business logic and the infrastructural code, then you can gradually build a pipeline like this. So here I have a step two, which is basically this step. And then you just glue it together, and that's it. The nice thing about working like this is that everything is represented as a code. And as I shown before, you have Git available, so you can version and you can collaborate with your colleagues and trace the differences, etc. So this is quite nice. Another thing that is very nice about when you are in a position like this, when you have a pipeline ready, is that you can start experimenting. So pipeline is nothing else, just glued code, and only few parameters are presented. And those parameters you can change, and you define which these parameters are. So here I'm going to assign my pipeline to an experiment that I created. And I'm going to now run 3 different experiments with different model training parameterizations, which I prepared here. So bear with me. This is going to be a bit manual. So I'm going to copy over some uh, some parameters and run the same pipeline 3 times. So this will be the first time, and I go back to the pipelines. I'm going to do the same. So I create a run, I assign it to an experiment, and I will
Well,
do.
Rado fills out the numbers. So the interesting thing here is that you just run all these experiments in parallel on your Kubernetes cluster. If you're running in an old-fashioned statistical modeling software, you run one experiment and the next one. But here they all run together, and you just take whatever capacity you need, and you're done quite quickly, even if every experiment takes several hours, because they will run in parallel for several hours, and that's it.
Yeah, exactly. This is really nice. For instance, when you're training neural networks or something more complicated, you can let it run over the night, and in the morning you just come back and you come back to your screen with all the different runs. And you can see here on the right hand side, I have a little summary of how my model was trained. So what is the AUC on the test and train? And you can see I have results of my first model. I will refresh it. I also have results of my second specification that is doing a bit better, and my third training pipeline is still running. Let me refresh. Okay, and there we go with the results. And you can see that my third specification is the best in terms of fit. And obviously, in a real world, this could take hours. Now, this is not something that is hard coded. You can also define what kind of metrics you want to see. Now, once you've done your experiments, you can dive deeper. So let's say I like I like this particular pipeline, and this is the model that I would like to put into production. So I can click on it, and I can also, for instance, explore a bit some more things just to make sure that the model is really okay. So I have a run output. I can see that my AUC, but I also can see Guinea. I can see my rock curve, confusion matrix, and so on and so forth. Now, another thing, and now I'm going to go a bit more technical, is that okay? Let's assume that we like this model. This is the model we want to put into production. And as David mentioned, in order to do it, you need to hand it over to DevOps, who will build an application from this model. And this is quite critical step. In order to do this correctly, you need to hand over all the artifacts. So basically your input data, your model file. If you have some feature generators, then those as well. You need to hand them over consistently to DevOps. And in order to track what are the artifacts from each of the training sets, there is an artifact pane here where you can trace it. So basically, in each and every experiment, you can trace. Okay, this is, for instance, in this experiment, I'm tracing the metrics, I'm tracing the model, and I'm tracing the input data set. And for instance, when you click in the model, you can see some more information about the metadata. You can see where you stored your model. So your models are not lying around your cloud, etc. You can see what type of a model it was that you used. You can see version, etc. So this is then pretty convenient because you have a unique ID for each run with which you can communicate with the DevOps. So that's like a bridge between the two worlds. All right. Um, Fine. So that's these are the metadata. That's quite important. And this is mundane at best, but it's quite important for the real world operations. And why it is important, I will try to motivate now. So now I'm back in my example. And what we've seen so far, there were 9 days of my simulation running. The model was doing fine. We have a very low PSI, so everything looks good. But the question is, and let me now resume my simulation. The question is, what happens if suddenly there is a certain change of economic behavior on the markets, and the input data, or the markets change. And this could be, for instance, triggered by economic crisis or post-corona crisis, something like this. Uh, and out of the sudden, the input data to the model are different. And as you can expect, the model will not react so good because it has not been trained for such a structure of the data. So in simple words, your data generating process changes. And when that happens, you can see that on day 11, I introduced the shock to the data, and immediately I have a spike in my PSI. And it's going to look like this for the next few days. And these are actually the terms when these are the times when you know, okay, something is going wrong, and I need to react, and I need to react fast because we are in a real-time world. So every day counts. And this is really the part. You see the average PSI is increasing, and at certain point it will go to a stage where you really have to retrain and redeploy your model or switch it off. And if you're lousy with your retraining, you are losing money. And if you don't retrain, you are losing money as well. So it's kind of a lose-lose situation if you don't do anything. And these are actually the times when having MLOps, like when having a process is engineered in an MLOps way, that's where it makes the most sense. So what I'm going to show you now is, okay, I will stop the simulation. I think everyone is convinced now that things are going wrong. And what I'm going to do now, I'm going to show you how I would approach this if this was a real situation. So first I would go to my experiments, and sorry, to my pipelines, and I already have a training pipeline for the model that is in the air. So what I need to do, I just need to create another run or a few of them and retrain my model. So in this case, you see I have a data window, which means that I'm taking the last 4 days of data, so the most recent data. And the idea is to retrain the model on the fresh data. So that's what I'm going to do. So now I rerun the very same pipeline. So all the steps are going to be the same, with the only difference that I'm using the fresh data. Now, since I'm doing this in the real life, in the real time, we really have to wait until it finishes. But it shouldn't be a lot. It should be a few seconds. Um, so now my model is being trained. We can also see some logs. We can see the artifacts. There are none in this step, but there are some artifacts here and some logs here. Yeah, so the model training has been done. I can see, yeah, that the model has been retrained. It looks also already better. It looks quite fine. So I can now just redeploy this model. I can go into my artifact and check what is the unique ID of my model, um, which is which is which is here. It's basically a timestamp. I'm using a timestamp as a version. So I can just copy my version and I can go into my deployment script, which I have just below here. And I need to, now bear with me, I need to manually change some stuff. So I need to change my model version in my model class. And I also need to do it here where I create the endpoint. So these are still a bit cumbersome steps. Okay, and now I will rerun my deployment script. So basically now I'm again rebuilding my new web app based on the model. So I injected the new model. I'm creating a new prediction endpoint.
Rado,
And
yeah,
yeah,
okay, I'll let you finish this story, and then we have a question on Azure ML versus Kubeflow.
yeah.
Yep.
Well, yeah. I need like 2 minutes, and then we have 10 minutes for discussion. So I have my prediction endpoint ready now. I can just take it and copy it. Let me resume my little controller here, and I will just redeploy a new model in my simulator. And you should see that from day 18, the PSI here will decline again, which is a good sign, which basically means that my model has been retrained on the new data, and it's again forecasting fine. And that's basically what we want. The whole idea here is that we want to quite quickly react to the economy, well, to the turmoil on the market. So that is what is happening, as you can see. So on date 18, we are back to normal, and the average PSI will also decline as we go as we continue. So this is pretty much it from what I wanted to show you. What I hope that you took away from this story is that there are many people who talk about this, but we actually shown it to you in real life. It was operated by one guy, by me. So you can really do this thing. Is not so complicated. David,
Yeah.
over to you. Yeah, I need to
So there is
share
this
it.
question on why should you use Kubeflow in Azure while Azure ML is also available. Can you compare the two solutions, or do they serve a different goal? Rado?
Yeah, sorry, I was switching off my screen. I'm reading the question. Can you compare the two? Well, there are the business solutions that David was mentioning. So Azure ML is not the cheapest one on the market. Also, you are tied to Azure then, so forget about migrating or working on premise. So these are the aspects that David touched upon. But also from the if you go deeper, the solutions are different. Kubeflow is 100% Kubernetes native, while Azure ML is not, as far as I'm concerned. Azure ML is putting together different virtual machines, etc. So, and being 100% Kubernetes native is quite good in some cases. So there is also technological difference between the solutions.
Another thing worth
Yes.
mentioning is that the community really works towards MLOps much more than a general purpose solution. Azure ML is much more generic, and you will have to combine it with a number of other Azure services. I think the total cost of ownership will not be the same, and it will be complex in its own way. Because it's just a much more generic suite, and Kubeflow, well, we see the community moving, it really moves in this MLOps direction. So the pipelines were there, you will see them in the other products soon as well, but they keep on moving, so they're kind of front runners in this area. Did we answer your question by that or not, Hans?
All right. Hans said yes, so.
Sorry, I'm always
fine.
looking at the top of the screen, so I thought Hans said nothing. Thank you. Is YQ only applicable
Another
for
question from
Stefan?
Yeah, go on, David, sorry.
Is YQ only applicable for banks and insurers? No, I mean, this is our home turf, banks and insurers, but it's perfectly generic. In some sectors, it will be more relevant, of course, those that really need heavy number crunching and lots of models than in other sectors. But sure, I mean, you can use that just as well in retail, pharmaceutical industry, etc. Mainly the higher end ones that need security and configurability. Which is also one of the reasons why we opted for Kubeflow and not just working with Azure ML. So the clients typically have very specific requirements, and we can actually fulfill them, each one of them, which wouldn't be the case when using the more generic solutions on the market. Okay.
All right. We still have time for one last question, and then, or maybe two, and then we can close.
Yeah, I'll take over the screen again.
All right, I'm scanning if there are. I'm scanning the chat if there are any questions. But they're not, so maybe David, you can close, and maybe there will be still some popping up.
Yeah. Okay. So I hope you enjoyed our story on MLOps and we got the message across. Gerben, okay. What's your opinion on the benefits of MLOps regarding non-ML data solutions such as web scrapers or complex ETLs that use many web APIs?
Well, I have an idea about how to answer the first part. For instance, we've shown this in the machine learning context, but not so much, to be honest, because the credit risk example that we show is really hardcore statistical modeling, is not machine learning so much. So by this, I think we answered the question. I can also see this kind of technology being used for other use cases.
Well, there are.
So you're asking more.
Yeah, I'm starting. Well, the web scrapers confuse me a bit, but we're using this also to set up ETLs that are quite complex, actually, and that also need automated testing and automated deployment and need constant changes. So that's not machine learning, but just data products, but it's equally valid and equally necessary in that case. Whether you use web APIs or not in them. Is that the answer to your question, Gerben? Or yeah, okay.
Yeah, it seems. Yeah, thanks.
Thanks, by the way, for having been a very vocal member of the audience. This picture is what we show at conferences. What we would have liked to show you in Utrecht or wherever in the Randstad this event would have taken place. So what we do is not just Azure ML, what you get there, but we really focus on the full factory. So you really want to be able to make and change lots of scripts, ETLs, web scrapers, whatever, ML products, automatically aan de lopende band, as we say in Dutch. That's our bread and butter. We have only a few minutes left, we know, but we reached the last slide. Yeah, so if you have further questions, so you see our contacts here. So my email address in Belgium, Rado's address, in Belgium as well, or you can also contact him via phone in Prague, or you can just go to our website, www.credo.be, and you'll find us back. So no problem if you want to chat about Kubernetes, Kubeflow. We're very interested, and also if you've questions about other solutions, the comparisons are also interesting for us. So please do get back to us, and thanks for being a great audience. And see you again maybe next year. And may God may it happen in real life. Actually, okay, that's my big wish.
Yeah.
Okay, I'm going to close
Yeah,
here.
me too.
Bye bye.
Guys, bye bye. Have a nice day.